problem is kind of a beast. We've got a boat traveling, it travels 20 miles per hour in still water, and it travels for a distance of 48 miles up and then 48 miles back. The speed of the current is what? All right, so we've got upstream and we've got downstream we need to consider. And the equation that we have to look at is distance equals rate times time for this, because those are the variables at play here, and then that's the relationship between them. The distance then is 48 for both. So we've got 48 for both, up and down. The rate upstream would be the boat goes 20, but we've got to subtract the rate of the river. Simple vectors addition or subtraction for speed here, because obviously the rate of the water is affecting the overall speed relative to the ground. Downstream, though, we can add it. So the rate downstream would be 20 plus r, the rate of the river, or the rate of the current. And then in time, if I call this one t, this one has to be t minus 5, or 5 minus t, or vice versa, because we know we have 5 hours total for time. So whatever this one is, if 5 minus that gives you the remaining amount of time left. All right, so now distance equals rate times time. So we have 48 equals 20 minus r times t. And then over here we have 48 equals 20 plus r times 5 minus t. Now this is where it gets tricky, because we have two equations with two variables, so we're solving a system of equations now, but it's not that easy of a system to solve. I have to solve for one of these variables. The easiest is t. So I get this equation, t equals 48 over 20 minus r. And then over here I'll solve for t as well. So I'll divide by 20 plus r. And then I still have 5 minus t, so now I'll subtract 5. And then I'll make it a negative. I'll multiply through by a negative. So I have these two equations that I'll solve for t. I'll set them equal to one another, or substitute now. So I have 48 over 20 minus r is equal to, I'll write this as 5 minus 48 over 20 plus r. All I do is switch these two. Now I need to clear fractions by multiplying through by the least common denominator, which is 20 minus r, 20 plus r. And that goes through to everything. All right, so this cancels, and I end up with 48 times 20 plus r equals 5 times 20 minus r, 20 plus r, minus 48 times 20 plus r, 20 minus r. Now I realize that this is a lot of work, but we do need to, I'm sorry, this 20 plus r cancels, so that's not there. So this would be just 20 minus r. It's a lot of work, but we have to solve it from here. So distribute 48 times 20 is 960. If you FOIL these out, you get 5 times, this would be 400 minus r squared, because that's a difference of two squares right there. So that'd be 2000 minus 5r squared. And this would be minus 960 plus 48r. Now the 48r's cancel. I can add 960 to both sides and subtract 2000 from both sides. And that leaves me with negative 5r squared equals 960 plus 960 minus 2000. Which is negative 80. And then I can divide by negative 5, and that gives me 16. So r equals plus or minus 4. So we just ask for the speed, so it doesn't matter what direction the current is, so we go with just 4. Okay, the next problem has a circular swimming pool. So that would actually be a cylinder then. And then we also have a rectangular swimming pool, which should then be a rectangular prism. So it helps to look at a picture, I think, anyway. Helps for me just to label everything and get organized. So the circular swimming pool has depth D, so that'd be the height. And the radius, which is right here, equals 5 times the depth. The rectangular swimming pool has the same depth, D, but its width is 4 feet more than 3 times the depth. And its length, right here, is equal to 2 feet less than 6 times the depth. And it wants the ratio of the rectangular pool. So rectangular pool volume divided by circular pool volume is what we need to do. So we need to find the volumes of both of these then. All right, so that'd be volume of the rectangular pool is length times width times height, which obviously we need to use 6G minus 2 times 3D plus 4 times D, so we're just in one variable here. Same thing with the pool, it's pi r squared for the volume times the height, but the height is D, and then the radius is 5D. So we're going to plug those in. And then we want this ratio, and I don't know, we're going to try to simplify this if we can, but my guess is that we're going to have to enter this in. So we'll give this a try real quick and see if this works. All right, to simplify, well, I guess this D can cancel this D for now, right? Yeah. Let me write that back up here. All right, those D's will cancel. Let's see, if I simplify this a little bit, 6D minus 2 times 3D plus 4 all over 5 squared is 25, so I have 25 pi times D squared. Yeah, I don't know if it's going to simplify a lot more. I guess I can pull out a 2 from the this first quantity, leaving me with 3D minus 1 times 3D plus 4 all over 25D squared, but that doesn't really simplify. So I guess it doesn't really simplify. We're going to try entering that in, or this, doesn't matter, and see if it works. Yeah, I know it's tricky to enter in, but that ends up being the right answer then. Okay, the next problem says we have a concentration of a drug T seconds after injection is given by this rational function. It wants to graph this on a calculator. So I actually didn't know this, but apparently you can just copy this into decimals pretty easily. If you go to Webwork and you just highlight it and do Control-C, you can just copy it right in. So I've been typing all these in, and you can just copy them over, make it quicker. But here's our function. And then the question asked us, estimate the time which the concentration is the highest, correct at least to one decimal point past the one place past the decimal point. So the maximum would be, in this case, 0.229, I guess, I'll enter in. And then if this function has a horizontal asymptote, give its y value. If there's no horizontal asymptote, type in none. Now keep in mind that when we have an exponent that's higher in the bottom than it is the top, the horizontal asymptote is in line y equals 0. And that's exactly what we see when we look at this graph, right? Reaches y equals 0. So we put in the drug and it reaches its highest concentration after 0.229 seconds. And then as time goes on, the concentration of the drug falls back to 0. Okay, next question wants us to, we have an open rectangular box and it gives us the volume, and it wants us to write a surface area function in terms of side length x. So this box then has a square base, so helps to draw a picture a little bit, I think. It's got no top. So this is side length x right here and here. I don't know what the height is, so I'll call that h for height. Now the volume equals the area of the base, x squared, times the height. And they told us the volume was 4. So there's one relationship. Now the surface area is what they want us to write a function for. That's going to be, there's no top, so I'm just going to do the bottom, which would be x squared, plus all 4 sides. Now the 4 sides are just x times h, so there's 4 of those. 4 sides plus the bottom gives us the whole surface area. Now, I didn't want this variable h in there, so I have to get rid of that. So I'm going to rearrange the first equation into h equals I'll rearrange this equation into h equals 4 over x squared, and I'm going to plug that in right there. So it becomes x squared plus 4 times x times 4 over x squared. I'll try to simplify this a little bit if I can. One of these x's cancel with one of these, leaving 16 over x. So I have x squared plus 16 over x. And there's our surface area function. They wanted us to write that in terms of x, which I've now done. X is the only variable there. So that should be my answer.